everyone. In this video, we'll be discussing how to treat outliers. What are outliers? Outliers are nothing but the extreme data points that deviates from original distribution. So outliers are data points that deviate significantly from other observations. What is the importance of those outliers? Why we need to remove them? In case of data analysis, dealing with outliers is the most important thing because they will distort the analysis result and always lead to incorrect conclusions. So consider we are dealing with a cholesterol level column. In that, normally the typical range it follows is 150 to 300. When we have a value of cholesterol level 600, it deviates from this typical range, right? So this cholesterol level is considered as outliers. So there are different methods in order to handle those outliers. Let's discuss them. So there are basically two methods. One is visual method and we have statistical method. So in visual method, we'll be making use of matplotlib or Seaborn. Under it, we'll be making use of box plot. That is the best way in order to visualize the outliers. Then we have scatter plot. So in scatter plot, the value that deviates from the original data. So when we draw a normal distribution, that is normal distributed data, like in the original data set, if there is a point that mislead from this distribution, that is, if that data is more scattered, then we'll consider those data points as outliers. Then we have statistical method. In statistical method, we'll be making use of standard deviation and Z-score. Then we have IQR method. We'll be integrating this IQR method along with that of box plot and we'll be doing further analysis. So let's practically visualize all these methods. So for practical implementation from sklearn, we are going to make use of inbuilt dataset, that is the iris dataset. Under iris dataset, we'll be having 4 different columns. So we'll be creating a data frame. Under it, we'll have sepal length, sepal width, petal length, and petal width. First, we are going to discuss the IQR method. So under IQR method, first you have to understand what are quartiles. So quartiles are nothing but the percentile values Q0, Q1, Q2, Q3, and Q4. So Q0 is nothing but 0 percentile. Q1 is 25 percentile. What is 25 percentile implies? For example, if we are going to consider sepal width column. For a sepal width column, if 25 percentile value is 2, it implies that considering the whole data set, over 25% of data have the sepal width less than 2. So likewise, we'll be comparing. Okay. So that is what called as quartiles. Then Q2 is 50 percentile. That is our median. Q3 is 75 percentile. And Q4 is 100 percentile. We make use of a concept called as IQR. IQR stands for interquartile range. So it usually provides you the range of middle central 50% of distribution. That is, it has a formula Q3 minus Q1. Q3 is 75 percentile. Q1 is 25 percentile. So it will be covering middle central 50% data distribution. So we'll be making use of this IQR. So first we have to calculate the percentile value Q1, Q2, Q3, which is 25, 50, and 75 percentile. So we'll be making use of NumPy method, np dot percentile of. We'll be calculating the outlier for sepal width, 25, 50, 75. So we'll be getting 3 values. That is 25, 50, and 75 quartiles. Then we have to calculate IQR, which is Q3 minus Q1. And then we'll be calculating the lower bound and upper bound. This lower bound and upper bound are the condition in order to accept or reject the outliers. So Q1 minus 1.5 times IQR is calculated as lower bound and Q3 plus 1.5 times IQR is considered as upper bound. So considering the sepal width has lower bound of 2.05 and upper bound as 4.05. So the values less than, that is sepal width less than 2.05 and sepal width greater than 4.05 are considered as outliers. This is how we calculate the outlier part. So in order to remove those outlier data, first let me restart the kernel. So here, let us find what are the outlier data in Sepalville. So the value lesser than, we are going to apply the condition. So df of Sepalville lesser than lower bound, or the value higher than upper bound are considered outliers, right? So there are totally 4 outliers considering the Sepalville. So if you don't want the outlier data, then the values lying between 2.05 and 4.05 are the normal data. So we'll be extracting it. And we can deal with this data for further analysis. Since there are totally 150 rows, there are 4 outliers. Once after removing the outliers, we'll be getting 146 rows. So this IQR method will be made use of in case of box plot. So in box plot, we are going to analyze Sepalville. So since there are 4 outliers, right, in case of Sepalville, as you have seen earlier, so that 4 outliers will be shown in case of box plot. That round part is nothing but those outliers. Okay. So this is a visual way where we can deal with outliers. Next, we are going to see how to handle outliers using z-score. So z-score formula is x minus mu divided by sigma, right? We are going to consider Sepalville. X is nothing but the Sepalville column. Okay. Here we'll be passing the data and mean of those Sepalville has to be calculated. Standard deviation has to be calculated. Z-score is nothing but data minus mean divided by standard deviation. So for each and every value of Sepalville, this z-score will be calculated. So I'm creating a data frame for Sepalville and z-score. Once after finding this z-score, we have to consider, we are going to calculate the outliers. So in case of normal distribution, once after applying standardization, we'll have mean 0 and first standard deviation are nothing but lying between minus 1 till 1, second standard deviation minus 2 to 2. Then this would be the third standard deviation. So the data greater than third standard deviation and lower than minus 3 standard deviation are considered as outliers. So this is the outlier part. We are considering the same Sepalville, but in case of IQR, we'll be having 4 different outliers. But in case of z-score, we are getting 1 outlier. So handling of outliers by each and every method will be different. So in case of z-score, it has shown 1 outlier, right? Let's visualize it. So there is a Sepalville his plot. So in his plot, this is the mean part. This is the first standard deviation. This is second standard deviation. So I have made use of vertical and axis vertical line concept. Okay. In that, manually, we have extracted the outliers, right? The 1 outlier data points that we can visualize in case of Sepalville that's following a normal distribution. So here, there is only 1 data which is greater than plus 3 standard deviation. So that value is extracted. So this is how we handle different types of outliers. We have different methods, both visually and statistical method. That's the end of treating outliers. Thank you.